Hello, everyone, and welcome back. Where we've been doing FRQs for the most part, but yesterday we did something a little bit different. We did the CSA Mock Exam 1. Today we're going to be tackling number 2. This is kind of supposed to be these are some samples they've put out to be the most realistic as to what our exam should look like this year. And so we see that this one is dealing with an array or array list. And a couple of notes when we get started here. Assume that the classes listed in the Java Quick Reference have been imported where appropriate. No need to import anything. You can assume everything's imported. One that I kind of glossed over yesterday, didn't really mention, but unless otherwise noted in the question, assume that parameters and method calls are not null and that methods are called only when their preconditions are satisfied. So the precondition thing, yeah, that's generally there, but this used to be something that was very particular on just certain methods, right? Here's kind of a sweeping statement that we can assume that things are not null, meaning we don't have to check for them, okay? In writing solutions for each question, you may use any of the accessible methods that are listed in classes defined in that question. Writing significant amounts of code that can be replaced by a call to one of these methods will not receive full credit. That is, you generally have to, in writing these methods, if they can refer to methods that were written maybe in another part or methods that already exist as part of the question, you need to use those as opposed to basically rewriting those whenever you need them. That's generally always been the case. Typically, they say that you have to call the other method to even receive credit, and that's basically the same thing here. So let's get started with this question. A school district would like to get some statistics on its students' standardized test scores. Scores will be represented as objects in the following score info class. Each score info object contains a score value and a number of students who earned that score. So we see this object that just contains two instance variables, two integers, the score in question, and then how many students received that score. Whenever we create the score info object, we're going to specify a score, right? And then we use that to actually initialize the instance variable for score. And num students starts off at 1. So we basically are only going to make a score info once someone has actually achieved that score, and we start out at 1. With this implementation, we just need an increment method, which increases how many students. So once we have a score info object that exists, anytime any subsequent students basically achieve the exact same score, if we already have a score info for it, we just increment the number of students. We have get score, which is going to pull out the score, and get frequency, which actually pulls out number of students. Kind of wish this getter was called something else. So this is an object that they give us. Of course, we are going to end up having to copy and paste, recreate this inside of IntelliJ in order to actually test it. The following stats class creates and maintains a database of student score information. The scores are sorted in sorted order in the database. The scores are stored in sorted order in the database. What does sorted order mean? He asked out loud. Ascending, descending? I need more. We have this stats object, and here we see an array list of score infos. That is the objects that are created up here. And that is called score list. We see the record method, which takes in a score, and this is what we're going to be working on in part A. So why don't we pause it there and actually get started on this. I'm going to open up IntelliJ. Let's do File, New Project. I'm going to go Next, and this one is going to be, what did I call the other one? Mock Exam 1, I believe. Under our FRQs, yeah, Mock Exam 1. So let's call this one Mock Exam 2. Going to expand my project folder, right click on the SRC, make a new Java class. This is called score info. This is the little object class, the starter class that they give us. And I'm going to pull this over to my other screen because unfortunately I'm unable to copy and paste at the moment. And we're going to take some liberties here. We're going to create these two integers, score and num students. Okay, and then once I have instance variables in IntelliJ, I can start auto-generating code with Alt Insert. We're going to insert a constructor, and this is only using score. Okay, so you see we're going to take in a score here. We'll save that into our instance variable, right? This is basically the same technique that they were doing in the actual code. Here I'm using this dot notation, whereas that's outside the subset, so they were not. So there's our constructor. We then have this increment method, which all it does is increment our number of students. Maybe we'll go ahead and Java doc that. Adds 1 to the number of students who earned this score. We're going to have a getScore method, which I can actually alt insert that one. Ta-da! Oh, and I like this. I like this this Java doc here. Sorry, I'm fat fingering some stuff at the moment. But this returns, wait for it, this score. That's what it says. Can't make this stuff up. And last, what we have is actually a getter for the number of students, but they called it get frequency. Again, I'm not a big fan of that. Just follow the convention like an adult. And this is going to return the number of students who earned this score. Okay, that's our little starter class. It's a score info class. It's used to make score info objects, and all it really does is wrap these two integers together in one object so that they're always joined at the hip, if you will. So the next class, which is where we're actually going to write all the meat of this, is stats. And stats relies on that score info class, right? We see an array list of score info objects called score list. And we need to import this. I'm going to hover over it, hit Alt Enter. They do have a single line comment here. Listed, here it actually says increasing. Listed in increasing score order. No two score info objects contain the same score. That is, once we have like a score of an 82, there's only one 82 that can exist in the score list. Once we have a score of 99, there's only one 99 that can exist. Okay. Then we're getting to part A, public Boolean record, which is going to take in a score. And let's take a look at part A, and then we'll come back and fill out the Java doc. Write the stats method record. That takes a test score and records that score in the database. If the score already exists in the database, the frequency of the score is updated. Again, we can only have one score inside of our score list. If it doesn't exist, it gets created, is what record is going to do. If it already exists, we need to find it and increment the number of students that has that. If the score does not exist in the database, a new score info object is created and inserted in the appropriate position. That's important, right? Because it's going to be in an increasing order. We want to maintain that at every moment so that the database is maintained in increasing score order. The method returns true if a new score info object was added to the database. Otherwise, it returns false. Complete method record below. I actually really like where this is going. So I'm going to type up this Java doc. Records a score in the database, keeping the database in increasing score order. If no other score info object represents score, a new score info object representing score is added to the database. Otherwise, the frequency in the score info object representing score, referring to this parameter, is incremented. Okay, we have score, which is a score to be recorded in the list, and we're going to return true if a new score info object representing score was added to the list. thoughts otherwise. Okay, so we're going to take in a score, and our first job is to kind of find it in our score list. Now, if it doesn't exist, we'll create it and add it. If it does exist, we need to increment it. What's important to note is that we should only, I don't know what I was going to say. When we go to add it, it needs to be inserted in the correct spot. That is, this thing is going to be in increasing order. Okay. Of note, I feel like some of my students are probably like, collections.sort, but sort is only going to work if we were to write a compare to method for score info. I'm sorry, if we were to implement compare to and then write the compare to method, then yeah, you could just basically throw it into the array list and then sort it in increasing order afterwards. The fact that they give you this class effectively in its entirety means that that's not really an option for us. So what we're going to do is we're going to look through our score list, right? We're going to search through it, trying to ask, is our score already there? If we don't find it, we need to basically insert it where it should go. Now that could be a little interesting. Okay. I'm wondering if we could just like do a while loop. If I do a for loop. Let's try it with like a for loop. I believe that, I mean, there's probably the fact that this thing needs to always be in increasing score order, I think there's probably some interesting implementations that you can go with this method, record. None are jumping out at me, so I'm going to just like try a simple for loop approach and see if something strikes me as we go. So I'm going to loop through our score list. Now, of note, whenever we find where it needs to go, I'm going to want to insert it at that spot. And in order to do that, I'm going to need an index. I say all that to say we probably want a for loop, not a for each loop. So let's try looping through score list. Right? So I'll create this for loop as long as I is less than our score list dot size. We'll do in I++. Okay. What I want to do is pull out the current score info object. Keep in mind, score list is an array list of score infos. So I want to pull it out to see what is the score. So why don't we go ahead and just pull that thing out. So I'm going to create just a local variable here. Score info, let's call it SI is equal to score list dot get I. So I'm going to pull out that score info object. Okay, some of this code is probably going to be able to be simplified long term. And what I really want to know is if it's equal, I can kind of stop here, right? If SI dot get score. Keep in mind, SI is a score info object. I'm going to need to pull out the score. The reason being is that's what I care about. Now, this is an integer, right? This is a score info object, but SI.getScore, that is an integer. I want to compare it to this integer because those are primitive data types. We can use an equals relational operator here. I'm going to see, are those two things equal? If so, I have actually found the score that I was looking for. I don't want to create a new score info object. All we're going to do is take SI and we need to increment because we have found an existing score info with that score. Not only that, because we didn't have to create a new score info, we can also just stop right here. We can return false. Okay, let's kind of pause and take a look at this logic. We're going to loop through our score list. With each iteration, I'm going to pull it out. I'm going to pull out the score list info. I'm sorry, the score info from our score list. So I'm just working with that maybe for the rest of this iteration. Now this almost looks like, well, why not just use a for each loop? And it's going to be on the second part of this where we have to actually insert the new score info element. So if the scores are equal, right? I'm sorry. If the current score info has a score that is equal to the one that I'm looking for, then all we have to do is increment, and I return false because I have found a score info that has that score. We can stop our search there. This return will not only leave the method, we're basically stopping the loop. And so this is actually like really efficient. If I'm still here, what it means is they're not equal. Okay, so then we can check other things. I can check less than, I can check greater than, but because this needs to be in increasing order, the moment that I find a score that is greater than the one I'm looking for, I can actually stop there as well, right? If they're not equal, well, let's check. What if the current score is greater than the one I'm looking for? What that means is, since we're already past this, I've checked for equality. If I manage to encounter one that's greater, well, that means that it wasn't there because I'm already past this. But I did find one that was greater than what I was looking for. And so I can also stop my search. The reason being, this is where it needs to go. Okay, let me maybe show you an example. Why don't we actually type up some scores here? Maybe here. So let's say that we have an array list, and keep in mind, I know these are great scores. Keep in mind, it needs to be in increasing order, ascending order. Okay, now let's say that I want to record a new score of 50. What we're going to do is we're going to loop through here. Right? I would be here, this is my first score. I would ask, is 12 equal to 50? It is not, and so we'd hit this else. We would ask, is it greater than? No, we'd keep going. We would ask, is 38 equal to 50? No. Is 38 greater than 50? No. We'd be here. We would ask, is 88 equal to 50? No. Is 88 greater than 50? Yes. What this means is I didn't encounter 50 because I've already checked for the equality. But this is where I want 50 to go. I want to insert 50 right here. And because of the array list, that's going to cause things to push. Okay? And so what that means is the current value for I, right? In that example, I is right here. Well, I want to insert 50 right there. I don't want to delete the 88. I want to insert 50 and push the other things. Okay? I don't have a quick reference page handy, but what we can use is just our add method. If I manage to encounter a score that is greater than what I'm looking for, right here, we want to add our new score at that spot. Now, it's not just an integer, it's ultimately a score info. So I need to make it, right? So we're going to take our score list and I'm going to add to it. Not at the end, specifically, I'm going to add to it right here. Okay, some of you may be thinking, isn't that going to increase the size and maybe play with my loop? Well, as soon as I add my new score info, right, it's going to be using this current score, I'm also going to return true, which again is going to bump me out of the loop. Okay, so let's follow this example again. I want to add 50. We're going to loop through. This is the first score info. We're going to pull it out. We see it has a score of 12. I would ask, is 12 equal to 50? It is not. Is 12 greater than 50? No. We're on the next score info. Is 38 equal to 50? No. Is 38 greater than 50? No. We're here. Is 88 equal to 50? No. Is 88 greater than 50? Yes. I'm going to take my array list. I'm going to insert at this index 50. When I do that insert, because this is an array list, those other elements are going to get pushed. And then we return true, which would cause us to leave the method. Now, you see that IntelliJ is still mad at us because we're saying we're going to return a Boolean. This is outside the loop. I need to return something. The reason being, you and I can see that this should always happen. right? However, from a compiler standpoint, what if this is false just right away? Just in theory, right? If we encounter our for loop and the condition is false right away, then I have no iterations. We never enter the body and nothing gets returned. You can just return basically anything down here. I'm going to return false to satisfy. Let's try this out. Okay, I'm going to right click on the SRC, make a new class called driver. And the first thing I'm going to do is plug in my main method. Let's make our stats object. Sure. I usually like to call them something else so I don't confuse people. Okay, initially there's nothing in this, and that's perfectly fine because the way that we're going to actually populate this object, that is get things in it, is by calling our record method, which was for part A. I'll take statistics and I want to record a new score. Let's say 12. And let's record 38. And let's record 88. And let's record 99. Okay, I'm going to see what it looks like here, and then we'll try to do 50, and then we'll also maybe test duplicates. Now, in order for me to test this, we're going to want to see what the contents looks like. So as you can guess, I'm probably going to need some strings here. I'm sorry, some toStrings. So I'm in my score info object. I'm going to plug in a toString for that, public string toString. And it's just going to show me the contents of this object, which is going to be a score. And then why don't we do like a colon and then number of students. And then our stats object, similar thing. I need a toString. This is, again, just for my testing purposes. This isn't actually part of the question. And ultimately, I just want to return score list, which is that array list. So score list is an array list. I need to return a string. It's not going to force the concatenation here unless I tell it to. And there's a couple of options to do that. Sure. So I'm back in my driver. I'm going to print off my statistics. Let's see what it looks like first. I need to make sure that these things are getting in there. Don't we need a case to add the bigger if it's bigger than all the other scores? You are correct. Our score list size is 0. So we see this stuff. Did they give us a constructor? Did I just skip over it? Interesting. They don't give us a constructor. They do give us a record scores method. I'm going to create a constructor here. It's just a no args constructor because all it's doing is taking our score list and initializing it to a new array list. Oh, maybe this is essentially my else case. If I manage to, so what you were saying in chat, don't we need a case to add a number bigger than all the other scores? So, and that's kind of what we're encountering here, right? If our list is 12, 38, 88, 99, what if we add 100? Well, then effectively nothing happens. But in order for that case to occur, it means I go through the entire array list. So instead of a simple return false, I'm going to actually, if I make it to this point, right, if I'm still here in the method, I still need to add the score, and it's bigger than everything else. So I'm going to do that. We're going to add, just at the end, this new score info, right? I'm using the overloaded version of add, which appends at the end. But that does mean that I am adding something, so I need to return true here. And that's actually what's happening here. Initially, when I try to add 12, well, there's nothing actually in the list. And so it's not getting added. So this should fix this current problem while also fix a long-term problem. So we see our score of 12, one student has it. 38, one student. 88, one student, 99, one student. So first thing I actually want to try is let's take statistics and let's record like another 99. Right? It should not make a new object. Simply put, 99 should have now 2 students instead of 1. Oh, it would help if I would print that off again. And we see that. So that looks pretty good. Okay. Now what I want to do is try adding something that is in theory out of order, right? I did this in increasing order, but what if we come in and we try to take our statistics object and record 50? Right, I'm going to print it off after that. Now the thing is 50 should get created, but it more importantly should go in the correct spot, which it does right there. I'm pretty happy with this. I'm trying to think, like, I was thinking maybe some funky while loop could get us there, but I don't hate this, I'm not going to lie. Okay, let's look at part B. So for part B, write the stats method record scores that takes an array of test scores and records them in the database. This is going to, right away, I'm thinking part B is going to use part A because part A was a single record, and here record scores is going to record multiple, that is a whole array of them. The database contains at most one score info object per unique score value. Each score info object contains a score and its associated frequency, that is number of students. The database is maintained in increasing order on the score. In writing, record scores. Assume that record works as specified regardless of what you wrote in part A. So, okay. I actually think this is probably going to be like insanely easy. I'm going to scoot this over. Yeah, collections.addAll, I hear you. So we're going to do public void record scores. It takes in an integer array, stu scores. Okay. Ultimately, they have to get turned into score info objects. So the fact that we're working with an integer array here seems a little off, except the record method that we just wrote works with integers. So that's actually a good thing. And we have our param stu scores, which is an array of student test scores. Okay. Collections.addAll doesn't quite get us there. We want to use this method. And this is actually insanely easy. We're going to go through this integer array, right? Each is an individual score, and I want to record it. I'm just going to call this method on every integer in this array. You ready? For each int, which we'll refer to as score in stu scores, I'm going to do record score. That's it. Because here's the thing, all this stuff, the technical stuff dealing with this question, right? It needs to be in increasing order. We don't want duplicate scores. That's all handled by this record method that we write for part A. Okay, let's try it out. I'm gonna just get rid of all this real fast. And in order to test this, why don't we create an integer array of scores instead? And I'm going to use an initializer list. Let's use maybe some different numbers from before to show that it works. 742. And I'm actually even going to jumble it up. So again, that doesn't matter. Okay. So there's our scores. Oh, let's get some duplicates in there as well. I want to replace this with like a 38, and let's do like another 42. So I'm going to take my statistics object. I'm going to record scores, this integer array. And we should see, after I print it off, right? I'm going to have a couple of unique ones, but 38 and 42 repeat multiple times. So that shouldn't create new objects for those. It should just simply increment the existing score infos. So when I run it, there is 17. That's correct. There's 123. That's correct. There's 238s. Yep. 242s, 155, 199, and 100. And notice that it is in the correct order. It is in increasing order despite how it looked here. Easy peasy. Let's look at part C. I've learned my lesson about asking chat for numbers. Part C, a programmer would like to add the method getSeniorPercent to the stats class that will determine the percent of seniors who achieved a given score. Consider the following table, which provides data about a given school district standardized test scores. Here we see a score of 82, and 6 students got that. 3 of them were seniors, so percentage-wise, half of them are seniors. 91, one person got that, but they were not a senior, so no seniors. 79, 5 total students, 2 of which were seniors, so 40%. You get the idea. A call to getSeniorPercent with a score of 82 would return 0.5 as 3 of the 6 students scored this, right? A description of how you would change score info. Right? Score info is the object that is keeping our score and number of students together. So we're going to have to make a change to that, or just how would you change it? It could be multiple changes. Class, in order to support this modification, assume all appropriate corresponding updates were made to the record and record scores method in the stats class. You do not need to address these changes in your response. Make sure to include the following in your response. Write a method header for getSeniorPercent method. Okay, let's think about this. This is going in the stats class. I'll actually write it out. Am I able to highlight now? I promise you I wasn't before. Wow. Okay. So I'm in the stats class, and what we want is a method header for getSeniorPercent. Okay, it's going to need to be public, right? Because I would want to be able to call it from my driver or some other client class. The question is, and you can answer this in chat, what would this method return? getSeniorPercent, right? If we look back at our example, they actually kind of give us a good example. A call to getSeniorPercent with a score of 82 would return a value of 0.5. So I'm asking, what do we return here? It is going to be a double. Okay, so in this example, whenever we call the method, right, we get back 0.5, which is a double value. The name of the method is getSeniorPercent. And again, answer this in chat. What would we take in as a parameter? A call to getSeniorPercent with a score value of 82 would return a value of 0.5. Okay, based on the examples that they give us, I don't see anything that indicates to me that it needs to be a double. So I'm going to roll with integer here. The fact that this takes in an integer array, and the fact that the score, I mean, I guess this should tell us that we're only going to have integers, right? No, it's not half a senior. This represents a score. So what am I saying? Here, the value that we're taking in is a score. We want to know how many seniors or what percent of seniors got a particular score. And scores can only be integers as determined from this, right? The fact that the only scores that we're ever recording are integer scores. So our parameter here has to be an integer. That makes sense. Okay. So this is what our header would look like, right? But the rest of this is asking, identify within the score info any new or modified variables, constructors, or methods. Do not write program code for this change. Now, okay, so let's think about this. Really, each one of these is a score info object. Each column represents a score info object, right? Because a score info is going to have a score. We already have that. It's going to have number of students. We already have that. What's going to be new, something we need to track, is how many seniors. So a change that would end up needing to be made to our score info is num seniors. So I'm going to add this instance variable. Now, that actually seems pretty easy, but notice that the question is asking about constructors or methods. Is there other things that we would need to change here? Right? Whenever I create a score info, I'm going to pass in the score. It's going to create the number of students, but I feel like it's going to be more than that, right? So once we record a score info, not only, like here, this is just assuming it's a generic student. So another thing I think I would need is an overloaded constructor. Right? And what this would do is that whenever we create the score info, maybe this new score info pertains to a senior. And based on our current implementation, I like the idea of going with a Boolean. Is it a senior or not? Okay, so what we would do in this case is set score to score, right? Our instance variable. The number of students, that's going to be 1 as well. Okay, I'm going to fix this in just a second, don't worry. But what's new here is if it is a senior, we're going to do a num senior plus plus. Or, sorry, it could just be simply put to 1. Right, so this is a particular case where we're creating a score info, but it happens to be a senior. Now, I'm using a Boolean here. There are other ways that you could kind of implement this. Now, we're not going to basically implement this into our stats class with record and record scores because they tell us just assume that the appropriate changes end up getting made. Okay, so that's one of it. Now, I'm going to clean this up. So a technique that we could use here, some of you will notice that this and this are the same. Sorry, I guess we do need some logic here. It's not as simple as, well, yeah, I guess the big brain thing to do is if senior, we can do num students is num seniors is equal to 1. Otherwise, it is equal to 0. And realities are, once we have this constructor in place, this one can just call it. Right? This is, again, outside the subset, but it's a little something extra. I'm going to call this using some parentheses. So it's going to refer to a constructor in this class. Now, which constructor just depends on the parameters I provide here. I'm going to pass along score, and then I'm going to say false for my senior. Right? What this is going to do is call a constructor in this class that uses an integer and a Boolean. Well, that's this one right here. It will take in the score. It'll take in the value for senior. Right here, it initializes score. It sets number of students to 1. And if it is a senior, we set number of seniors to 1. If it is not, we set it to 0. And so this basically applies to, it's just a much broader constructor. Now, one last thing that we're going to need is we have, increment, which adjusts our number of students. We have get score. We got get frequency. But if now that we have this new instance variable here that represents the number of seniors, I need a way to pull that out. It is private inside of this score info object, and so I'm going to need some type of accessor method for that. So I'm going to pull out num seniors. Now, between these two methods, get frequency and get number of seniors, we could figure out a percentage from there. The last part here in part C says, describe for each new or revised variable, constructor, or method how it would change or be implemented, including visibility and type. You don't need to describe the get senior % method. Do not write the program code for this change. Okay, so they're asking you basically to be descriptive. What did we implement here? We implemented a private, that's the access level, integer that stores our number of seniors, and that's inside of our score info. It is an instance variable. We also brought in a new constructor. Now here we're using a boolean. There's other ways that you can identify is this a senior or not at the point where you actually call the constructor and create it. And the last thing we're going to have is this new method, get num seniors. That way that it is public. That way we can access from somewhere else the number of seniors that are inside of this score info object. And with that, that's the end of question 1. Do we submit a Java file for the exam? No. It's going to be completely, like you're going to get a question that looks just like this. And you're basically submitting, I believe, in text boxes. I'm not positive on this. I've thought about like looking at the stuff and going over it and presenting it to you, but honestly, one of the best ways you can get an understanding about how this is going to work is look at their official videos. All I would be doing is taking it and regurgitating a lot of the information, probably poorly. So what I am doing here is showing like my approach to these questions and hoping that I give you some insight there. We're going to wrap it up there. See you guys Monday.